Integration. Integration is the reverse process of differentiation. It's sometimes thought of as anti-differentiation. Let's consider some examples. We've got dy by dx, so the gradient function is equal to 2x. What would y be equal to? If dy by dx is equal to 3x squared, what would y be equal to? If dy by dx is equal to 4x cubed, what would y be equal to? If dy by dx is equal to x to the fourth, what would y be equal to? And if dy by dx is equal to x to the n, what would y be equal to? Y would be equal to x squared. Now, if we differentiate this, we should get back to this. So we bring down the 2 in front and reduce the power. We will, in fact, get 2x. Except, this could be x squared plus 5. It could be x squared minus 4. So we have to put in what's known as a plus c. This is known as the constant of integration. This one comes from x cubed. And this one comes from x to the 4. Let's just check. We get 4x cubed plus c. Now this one's not quite straightforward. Yes, it comes from x to the 5, but if you differentiate this 5 have to come down in front, and therefore we have to put a 5 down here in order to compensate, in order to get back to x to the 4th plus c. Can you now write down what the general form will be for this? We can see that this would have to be x to the n plus 1, the power increases by 1, dividing by the new power, adding in the constant integration. Can you see if there's any value of n where this will not work? If you look at when n is equal to minus 1, we're going to get minus 1 plus 1, which would divide by 0, which we cannot do. Therefore, we have to have one exception to this, which is looked at later on. So provided n is not equal to minus 1, this formula will work for integration. Now, if we differentiate any function x squared plus c, we'll get back to 2x. Let's just look at that graphically for a moment. So if we go to an autograph file and go to entering an equation, and we'll put in y is equal to x squared. For x squared, you can just press x twice, plus c, and edit constant. So we'll put the startup value as c is equal to 0. Okay, and we'll press OK, and it will draw the curve y is equal to x squared. Okay, if we now hit the constant controller, which is this one here, and go to options, okay, and we'll do what's known as a family plot, and we're going to start it at -2, and we'll just leave it at 10 to finish off, and we'll go up in steps of 1. Okay, and we press OK. All right, and then let's just click this one, okay, and let's convert it to a static text, and then we'll just get rid of this bit and this bit. So we're just left with y is equal to x squared plus c. Press OK. Okay, and we'll just grab this yellow thing, we'll label that. That was the original curve. Okay, so what we've got here is y is equal to x squared plus c, but we've got some other values here. This is y is equal to x squared minus 1, y is equal to x squared minus 2, y is equal to x squared plus 1, x squared plus 2. We could have y is equal to x squared plus 1.5 or 1.4. Doesn't really matter. Okay, there's an infinite number of family of curves. This is known as a family of curves. So here we have a screenshot of what I've just done. And this is known as a family of curves. Here we're just going up in steps of 1. We don't necessarily have to go up in steps of 1. Okay, the notation for integration. The notation has two parts. It has this part here, an elongated s, and the dx. This tells me integrate x to the n with respect to x. So integrate with respect to x. So there's two parts in the notation, and students are notoriously bad at this part here, leaving this part off. It's two parts of the notation for it to be correct. We know that this is equal to x to the n plus 1 over n plus 1 plus c. And I can put a constant in as well. So if I put a in like 2x to the n or 4x to the n, then the constant stays the same. So this is true provided that n is not equal to minus 1. Okay, so there's a little introduction there to integration.